mathematics, and today we are doing these two questions based on chapter 10 heat, and this is lesson number 9. So let's start with question number 10. I'll just write down the data. It says here 1 kilogram of water is contained in a 1.25 kilowatt kettle. So the mass of water is given to you as 1 kilogram. Let's say this is M1. And in a 1.25 kilowatt kettle, so the power P is equals to 1.25 kilowatt. Let's convert this kilowatt into watt here. So 1 kilowatt is equals to 1000 watts. So kilowatt and kilowatt will cancel. So you get 125/100 times 1000, which will give you 1250 watt. This is the power. You also have, it also says that assuming that the heat capacity of the kettle is negligible, so calculate the time taken for the temperature of water to rise from 25 degrees centigrade to its boiling point at 100 degrees centigrade. So the temperature from 25 degrees centigrade, that is the room temperature probably, and goes to the boiling point is 100 degrees centigrade. You need to calculate the time taken. T is here, time. Let me just put it over here. Time. This is equals to how much? So, you know that specific heat is equals to delta Q upon the T, and or you can say that delta Q is equals to MC delta T. This is specific heat capacity. Okay, this is specific heat, and this is specific heat capacity. So it's talking about water. In water, you know that the specific heat capacity is 4200 joules per kilogram per degree centigrade. We're taking this as centigrade. And since this is given in kilogram, so we take this mass of water is 1 kilogram times 4200 times, what is the change in temperature? T2 minus T1. So T2 minus T1, and that will give you 4200 times T2 is 100 multiplied by minus 25. So you have 4200 times 75, and let's work this out. 75 times 42 would give you 2 5s are 10, 2 7 are 14, 15, 4 5 20, 4 7 28, 30, 0 5 1 3. So you have 3 1 5, and this is joules delta Q. Now we need to find out the time, and you know that power is equals to the right amount of work done, and over here the work done is the energy, heat energy we are talking about. So I can say that delta Q upon T, and since we need to find time, we'll take time over here, delta Q upon T. And delta Q we've just calculated, that is 315,000, 315,000, or power is known to us, it is 1250. 1250. This is to cancel. So 5 2s are 10, 11, 12, 5 5s are 25, 5 6 are 30, 10 5 3s are 15, 0 0. 5 5s are 5 1s are 5, 6 5 2s are 10, 11 12 13, 5 6 are 30, 0 5 2s are 10, 11 12, 5 5s are 25, 6 5 2s are 10. So you have time as 252 seconds. Okay, let's convert this into minutes. So 252 seconds. You know that in 1 minute you have 60 seconds. Seconds and cancel. 5 we can divide this 252 by 60. You get 4, 24, 0, 2, 1. 0.0, and this will give you 2. There you go. So 4.2 minutes, or we could say 4 minutes. And what is 0.2 minutes equal to in seconds? 1 minute is equals to 60 seconds. So this is compared to 6 o'clock. So we have 4 minutes, 12 seconds time it will take for the water to boil in the selected kettle, which is of 1.25 kilowatt. Okay, I hope it is clear to you all. Now we move on to the next question, 10.11. Now, this is an interesting question, and here we see that 10.11, 20 gram of ice. So the mass of ice, let me put it as Mi, is equals to 20 grams. Just change that pen. At minus 10 degrees centigrade. So the temperature, initial temperature is minus 10 degrees centigrade. It's converted to steam at 100 degrees centigrade. So the final temperature, that is temperature of steam, is 100 degrees centigrade. Find out the total heat energy required. So the total heat energy Qt is equals to how much to accomplish this change, given that the specific heat of ice, latent heat of ice, and latent heat of steam, okay, is 2.1 joules per gram, 326 joules per gram, and 2268 joules per gram respectively. Now, just remember that 20 grams of ice to change to steam, okay, 20 grams you could say steam. Okay, this temperature over here is minus 10 degrees. Now it goes through various process. Minus 10 degrees, then it will come to 0 degrees. Then you have latent heat of fusion taking place over here. That is, it will change from one physical state to another physical state. But there will not be any increase in temperature over here. As you can see, temperature remains same. Then 100 degrees centigrade, and finally, eventually, latent heat of vaporization over here, or latent heat of steam value is also known to you here. Now here the change in temperature is what? Delta T. Here it will be 0 final temperature minus this, minus and minus plus, so 0 minus and minus plus. So delta T is equals to 10 degrees centigrade. Here there is no change. Here you can see there is a change taking place. Delta T is equals to final is 100 minus 0, and that will give you delta T is equals to 100 degrees centigrade. And here you can see there is no change taking place. So we'll find Q1 over here, Q2, Q3, and Q4. Okay, and then we'll add all this, and that will give you the total heat change. Just put the value of delta. Right, so let's find delta Q1 is equals to mc delta T. The mass is 20 grams. As you can see over here, 20 grams, 20 grams. And specific heat of ice is known to you, 2.1. Change in temperature is 10. So this will give you 20 times 21 upon 10 times 10. Since cancel, 0 to 1 2 to the 4 joules. This is what delta Q1 is equal to. And the same way, let's find delta Q2. Delta Q2 will give you mass. Now there's no change in temperature, but since it's changing from one state to another without the change in temperature, so you have the latent heat of ice over here. Mass is 20 grams. The amount will remain the same throughout the whole process, that is 20 grams. And latent heat of ice, is 326. So delta Q, this will give you 2612, 2 to the 4, 5, 2, 3, 6. Hope I'm right over here, 326, 0. So 2612, 2 to the 4 and 5, 2 to the 6. So we now have delta Q2 as 6,520 joules. We then move on to the next step, and that is you can see over here delta Q3 is equals to, here there is a change in temperature, so we take the specific heat, and here we take the specific heat of water. And you know the specific heat of water is 4,200 joules per kilogram per degree centigrade. It's the temperature centigrade. And since this is given to us in grams, so we'll convert this into joules per grams per degree centigrade, and that will give us, dividing this by 1000, 1, 2, 3, 4.2 joules per gram per degree centigrade. This is the specific heat of water. So, specific heat of water times change in temperature, and here you can see the change in temperature for del Q3 is 100, so mass remains the same, 20, times specific heat of water is 4.2 times 100. So, shift this decimal place, 1 0 will come here, so 0 0 will cancel. So, we have 1 2, 1 2, zeros will come, 2 2s are 4, 2 4s are 8. 8,400 joules. This is what delta Q3 is equal to. Okay, and finally the fourth step over here, delta Q4, let me just put it over here, is equals to, here you can see that there is no change in temperature, latent heat of vaporization. Steam is taking place, so latent heat of steam, mass into latent heat of steam. Let me just, mass into latent heat of steam. Mass remains 20 grams, latent heat of steam, as you can see over here, is 2268, 2268, 0 to 8 are 16, 2 6 are 12, 13, 2 2 are 4, 5, 2 2 are 4 joules. This is del Q4. We just check it once again, 2 8 are 16, 2 6 are 12, 13, 2 2 are 4, 5, 2 2 are 4. Now, del Q P, that is total heat change. This is what they have asked for. Here is equals to del Q1 plus del Q2 plus del Q3 plus del Q4. So we have calculated all 420 plus 6,520 plus Q3 is 8,400 plus Q4 is 45360. When you add all this, let me just do it over here, 45360 plus 8400, 6520 and 420. 0, 6 to 8 to 10, 4 and 4, 8, or you could say 8 and 4, 4 to 12 and 5, 17. You have 5 and 6, 6, 12, 12, 13, 14, 15, 16, 17, 18, 20. And 4, 5, 6. So there you are. 60,000. 60,700 joules. This is the total heat change. 60700. This is the answer. Right. So I hope you have all understood this, and we just have one more question in the textbook to solve, and hopefully we'll do it in the next lesson, lesson 10. Till then, take care.